keyboard shortcut Control L just to give us a clean slate to work with, and I'll do that once in a while so that we're not always working from the bottom. Let's start off with the character type by just creating a simple string wrapped in double quotes. We can either wrap it in double quotes or single, but if you have, as right here, an apostrophe inside of your string, then you're going to want to wrap it in double quotes. So in this case, we're just going to assign the string to the variable s. Let's take a look at the class and type of. So remember that class gives us a higher level data type, where type of gives us a lower level data type. And we can see that there's no distinction between the two, which means that our string is indeed a character, even though it's actually a collection of characters, but it's still considered a character data type. There are a lot of different operations for working with characters, and we're going to take a look at some of them just to give a nice foundation. You should be able to do and explore a lot of operations with strings based on what we're going to show you here. For starters, we can convert a string that is numeric that is convertible to, so there can't be anything in the string non-numeric, but we're going to convert it to a float using the command as.numeric. So here we're going to assign that to x. We're going to print it out and do the type of. So we can see that on the printout we have no quotes, which you'd expect in a character type, and then its type of is now double. And then we can do the same thing by casting to integer. So this string, essentially what it's going to do is it's going to convert what's inside the string to a number, and it's going to truncate anything after the decimal, so it'll make it an integer. So here, as expected, we have the output of 1, and then its type is integer. All right, let's go ahead and clear the console. And then we can go in reverse as well. We can use as.character, and so we're going to convert this 1.23 into the character type. So we'll actually get a string of 1.23 instead of just the numerical form. So let's run these, and we can see that now it is a string and it is of type character. And one thing to add to that, let's just test something real quick. We'll do as character and we'll have true. So now we can see that what we get is actually just the string true. So we can also convert the logical or Boolean types into character as well. And if we wanted to do as logical, didn't mean the extra parenthesis there, then let's type true. And you can see that we can also cast in that form as well. Okay, so a number of methods that we want to take a look at, aside from just casting, is kind of getting strings to do some of the things that we want and combining strings. So Sprintf is one very common method, and it's used for formatting strings. So this is essentially a print method with formatting. You can think of the F as for formatting. Alright, so this string, we're going to create this, and it has two placeholders. These percent signs, these are essentially called literals, and then we put a particular character after it to tell the formatter what it should expect. In this case, the S is telling it to expect a character type or another string, and then the D is telling it to expect an integer. So we're going to, or something that looks like an integer. So what we're going to do is assign that, and then we're going to create this var name, and it's just going to be our string that'll go in right here. So it's going to have this character capital N. So if we create that, and then we're going to assign also to an actual variable called N, we're going to assign it the value 7. And then we're going to run sprintf. So var name is assigned to this literal because of the order of the string, order of where the literals come in the string, and the order of the arguments in the sprintf function. And then the value of n is going to be assigned to this right here, this literal. Alright, so once we run the sprintf function, we can see that the value of n is 7. So it just fills those values in for us. So essentially we can keep this string around and we can pass different values to it. So once more, if we do sprintf, we're going to use that same string, but let's change the values. Let's call this capital X, and then let's pass the value 20. So we can see that the value of x is 20. So That's how that would work for us. And as far as literals go, they're actually pretty easy to use. So in this block of comments right here, you can get a pretty good idea of that. So again, S tells it to expect a string, while D, or also %i, expects an integer. Now for numeric objects, we can use F, think of that as float. E is going to give scientific notation, and then we also have the G or A. We don't need to get into details of all of them, and I won't show examples for all of them, but you can play around with those. Okay, so a little bit further into the formatting, you can also use these literals in order to specify the actual precision for when you're doing numeric or float data types. So we're going to see a couple examples here. The value we're going to pass in is going to be just really simple 1.12345. The reason for the 12345 is that way we can actually more easily see that precision and how it comes out. So let's go ahead and run that one. And we can see that the string is n equals 1.12. Okay, so what happened to the 345? After the literal, but before the actual type to expect, we put this 0.2 here. So basically what it's saying is after the decimal, it should have a precision of 2. So we should expect only 2 things there. And then, actually, before moving on, let's give one more example. Let's do Sprintf n equal dot, let's say 15. Okay, so what we did there is we told it should have a precision of 15 decimals. And since we don't actually have 15 decimals, we ended up with a bunch of zeros. So that's what's going to happen if you specify a precision greater than what you actually pass in, is you'll end up with the zeros there. And then similarly, we can actually pad behind it, but don't worry, this isn't going to place zeros, because numerically it doesn't make sense to have zeros or preceding zeros before the decimal. So this 10, we have 10.3, what that's going to do is allow up to 10 digits, and if there aren't that many digits, it'll just put white space behind it. And then we're going to have a decimal precision of 3. So in this case, we print it out, we're going to have some extra padding here. And that kind of format is really nice for when you're trying to construct printed messages. When you're running certain algorithms, you may want to print out messages that always are nicely aligned. And so this is just going to fill in to the left as you increase the number of digits that you have here. So if we were to run this again, but change something just a little bit, let's do, I don't know, 1, 2, 3, and 3, 2, 1. So if we were to run this, then you can see now that it's actually filled in to the left quite a bit. And you can also see that the decimals are aligned. So it's expecting a total of 10, and now it has them. Okay, let's clear that console. And again, if you want to delve deeper into it and see some other examples, you can run the help command on Sprintf. Okay, the next operations are for combining strings. So there's paste and paste 0. Paste by default combines things, or strings, combines vectors essentially, combines them separating with a space. Whereas paste 0, its default separation is nothing at all. It's going to combine them directly. So we can see this here, this example of what it should print out. So it'll be a space string, because we're pasting a and string together. And this one, because it has a default separation of no white space at all, it's just going to combine it directly, so it'll be a string. Let's run each of those just to see that. And we can see as expected, it has printed those values. Now what we can do, so in paste, we're going to specify a separator. So all we have to do is give the argument of sep equals and whatever our separator should be. In this case, we're giving it a hyphen. So if we run that, we can see we have a hyphen string. And then we can also use this for zipping sequences together. So instead of just combining these two things directly, what we're going to do is pass 2 equal length vectors, and we're going to essentially zip these values. So 1 would pair with 6, and 5 would pair with 10, and everything in between. And because paste has a default separation of a white space, then we can see that we actually have 1 space 6. And yes, while we passed in numbers, it's going to actually pass out or return strings. So we have a string combined of 1 space 6, 2 space 7, 3, 8, 4, 9, and 5, 10. And then paste 0 will give us these things zipped together with no white space at all. So paste and paste 0 are really handy for combining sequences or different strings together. And one other thing that we have for characters is nchar. So in Python, we would just use len for length. In this case, in R, we're going to use nchar, N-C-H-A-R. And here we just have a string that we're passing in there, counting characters. So if we run that, we can see that it counts those characters, counts everything for us. That includes the white space, and that gives us 19. And let's see, I think this is probably pretty close. Okay, so we have 2 more operations we're going to take a look at with strings. We're going to get slices from strings, and then we're going to use substitution. So I'm going to clear our console again. So for the first thing, we want to get slices. Let's create this simple string of 1, 2, 3, 4, 5, 6 so that we can easily select or see that we've selected indeed what we want. So S is now the string 1, 2, 3, 4, 5, 6. And we're going to use the substr or substr command for substring. The first argument is the string. The second argument is the start index, and then the next one is the stop index. And this is inclusive on the stop. So if we tell it we want 2 through 5, then we get 2, 3, 4, 5 from the string, because that is the order that we have. And we can see now on the output that's just as we would expect. One thing that you may want to do is actually just extract, say, the last few characters. And in order to do that, instead of using negative values as you would in Python when indexing or slicing, what you want to do here is actually count, so we can put our nchar to good use. You want to count the number of characters in the string and then subtract from it. So remember, this is our start. So if our start value began at nchar, that would select just the last digit. So what we want to do here is start with nchar minus 2, so that'll actually go 3 backward. And then we want to go to the last one. So this will give us the last 3 letters of our substring, which is going, or our string, so our substring will be that, a quick brown fox. So we want the last 3 letters, which is going to be fox. And now if we run this command, as expected, we get an output of just fox. So remember that this one is counting that number of characters. That's an index. So that's starting at the last one, and then we want to go 2 before that to get 3, to get the last 3 to the end. Okay, so now on to the substitutions. Didn't mean to do that. Okay, so for substitutions, we're using this sub command. So we had substring, or s substr. Now we're going to be using just sub for substitution. And all we do here is we pass in a pattern to substitute, and then what we want the replacement to be, and then the string itself. So in this case, we have our string, which is the quick brown fox. But we're going to change it to the quick red fox using the substitution. So we run that, and it's going to look for brown. It's going to replace all instances of this pattern, which in this case is really simple. It's just brown, and it's going to replace that with red. So we pass that in, and instead of actually assigning it to a variable, we just printed it out because we had no anything equal there. We could have said s or x or whatever equal to reassign it. So now we have the quick red fox, as expected. Okay, so that is everything for working with strings that we're going to cover, and that is plenty to get you started. And I recommend you play around with that and come up with some creative ways to use these different methods. And so now we're going to move on to complex numbers. After that, we can move on to data structures, which we're going to split off into a separate video. First, I'm going to clear the console. Since the vast majority of you won't end up using complex numbers at any point, although some of you may use them quite a bit, it's a a reasonable assumption that most of you will never use these. So we're not going to cover them in depth, we're just going to give a really quick introduction to them. A complex number has two components, a real component and an imaginary component. So we pretty much always enter these with real plus or minus imaginary. In this case, our imaginary component is 2i, which essentially says it's 2 times the square root of -1. And if we were to run that, and also the type of, we can see that its type is complex. And then if we were to do the class of z, we can see that it is also complex. So the higher and lower level data types on this are the same. Now, this comment right here may be a little bit misleading. It says omitting the real component sets it to 0. So it's actually somewhat incomplete, that comment. It doesn't make it entirely clear. What it sets to 0 is the real component. So if it's omitted, we get a real component of 0. Let's see what that looks like. We'll set z equal to 1i, and let's just make a call to z, and we can see right here that it does still return the real component, it just has it set to 0. So we have 0 plus 1i. And as I mentioned in the slides, if we square just the imaginary component, if it's just 1, we would get -1, because the square of the square root of any number just returns the number that is inside the root. So we can see here by running that now that we end up with -1 plus 0i. So our imaginary component is 0, which just gives us the real component of -1. And that is it for the complex numbers. In the next tutorial, we're going to be moving on to the data structures. So again, this is split up into multiple videos, and I guess we will see you then.